Design a real estate marketplace like Zillow. Hey everyone, welcome back to another Engineering Manager mock interview with Exponent. My name is Kevin Wei, and on today's show we have Josefa. We're going to be doing a system design, a technical mock interview today. And before we get into that, Josefa, do you mind just telling the audience a little bit about who you are?
Sure. Hey everyone, this is Josefa. I'm an engineering manager at Facebook. I've been working in software industry for about 12 years, mainly on in the fintech space. So worked with PayPal, startup like Wealthfront, and excited to be here.
Awesome. Thank you, Josefa. So, like I mentioned, we're doing a technical system design mock interview today, and this is the question I'd like to tackle. Design a real estate marketplace like Zillow.
Got it. Like any marketplace is a two-sided network. So you have your sellers on one side and your buyers on the other side. So I think there are two parts to the system here. For something like a real estate marketplace, one is where you have aggregating all the information of homes in, let's say, if you're looking at US as only US, all the homes in the US, whether they are available for sale or not, aggregating that information. That's one part of the network. The other part is making that information available for people to kind of view homes and buy and sell. So let me just kind of start off with some requirements over here. So one is basically aggregating home information across the country. The next part over here is making this information available for consumption. The last other part I can think of, you could also talk about, is for users to claim a home and maybe update information about the home. Let's say some information is incorrect. Users should be able to rectify that information. So users able to update home information. So these are some of the core product / functional requirements that we would want the system to handle as an MVP. Some things on the non-functional side we could look at is that we want the system to be highly available. It needs to be low latency, so your search results need to be pretty quick. I think in terms of consistency, we can err on the side of slower consistency. This is need not be a real-time system where if something is updated, everybody need not see the information on at the same moment. It's not unlike a chat application. So we could look at eventual consistency over here. And the reason I bring this is how we design a database, what kind of caching we do kind of plays into that over here.
Got it. So what you're saying is you'll sacrifice some consistency just to have more availability and more partition tolerance.
Yeah, exactly. Cool. So let me just start off with the system. So as I said, it's a two-sided network. So first I want to kind of just at a high level go over what the aggregating part will be, and then next I can look at the viewing part. So basically you start off with a let's say on your marketplace site you have a aggregation service. So essentially what this service is doing is it is looking at different data sources, if you may, right? So thinking of this as one big MLS. So there are multiple listings that this aggregating service is kind of listening for. So it's probably you could look at some kind of polling mechanism that this aggregating system is polling to these different MLS to get this information. Once it has the information, I think the aggregation service needs to do a few things. So first, it needs to validate the data that it gets, whether it's accurate or correct or not. Outside of accuracy, whether the data is like you don't have malformed data, or you don't have someone injecting some incorrect data. The other thing the service might need to do is normalize the data. So as you are injecting data, getting data from different sources, that data might not be standardized across all of these sources. So before you store this data on your end, you would want to normalize, standardize that data. Once that the service does that, the next part over here, it would hand it off essentially to your database, and this could happen in some kind of a in form of a queuing system over here, right? So some kind of a message queue, like Kafka is pushing all of this data into the database over here. In terms of the database, as we said, right, that we want to sacrifice a little bit of consistency over availability and latency, right? So I was thinking using something like a NoSQL database here. One of the other reasons you want to use that is that there is no specific relation between homes. Every home is by itself. It's an individual entity. Also, there is a lot of free form data, and a lot of new fields can be added constantly, right? So as over time, as data gets richer and richer, and the aggregation service is able to pull more and more data, we can keep adding more and more information over here without having to worry about columns and how the relations play into each other. Plus, I think SQLs scale very well as well, so that they are highly scalable, right? So that's from the aggregation side.
Got it. Can we also talk a little bit about database sharding and how you would approach that here?
Yes, I'm going to talk about that on the next part over here. I'm going to get to that. Cool. So on the user side, basically think of it, we have users over here. Any big marketplace will have multiple servers over here. So you can think of you have a load balancer. The next part over here is you can think of is you have your search service. So basically, the user makes a request, it's going to the load balancer, right? Like you're looking at some search endpoint over here. Now I'll get to the sharding part over here. So on the database side, essentially our main the database that is storing over here is storing all this information for all the homes in the country. So obviously, if you were to try to pick out one home from this, you would have to search through the entire database, and it would take too long. So we would, as you said, we would need to shard this. Given that we are looking at homes, we could shard by geography. It's a very logical way to shard homes. So you could look at zip codes by which you want to shard, and based on the density of homes within that zip code, you can even further shard it even more by streets or by blocks, right? So I think, at least right now, for the sake of simplicity, let's say we are sharding by zip codes.
Yeah, zip codes make sense, but if I were to challenge you a little bit more, can you think of one or two other methods that would work for sharding?
Sure. So other methods outside of geography?
Yeah.
Yeah. let's say you could shard by type of home, whether it's a single family home versus a townhouse versus a condo. So that could be one type of sharding. You can also shard by price range. um, on that, if I extend that, you can also shard by, how big the home is, like a 2 bedroom, a 3 bedroom, baths and all of that, right? So there are various parameters within for a home that you can shard with.
Cool, makes sense. Yeah, I think geography makes the most sense here, but thanks for going off on that branch there. Let's continue with sharding by geography.
Yeah. So let's say we are sharding by geography over here. So essentially, what I would see happening is that we have a bunch of shards over here. Like, I'm just kind of trying to represent them here, right? So these are your different shards. Um, you can think of it as geo shards here, right? And essentially, the way it would work is that this database is taken here, and then you're sharding into this, right? The other thing over here, I would say that is, this database here, we are optimizing for reads. So it's some kind of a in-memory database, like Redis, so that you're reading faster. So the number of reads over here will be way higher than writes. So that's what you are optimizing for. So this is like your database.
That makes sense. Yeah, more people will be reading and looking up homes rather than
Posting. Yeah, exactly.
homes.
Yeah. The other part, we could now look at updating home information. So I think the way we would do that is, we would want one database as a source of truth, and we would use this database as our SOR, which is a system of record. So in case a user wants to update any home information that they've made, let's say they've made upgrades to their home where they've changed the layout, so it becomes, they've increased the number of square footage, or changed things in the homes, it would essentially be like a some kind of an update service, and you essentially are going from the database, from your load balancer to this service, which would in turn essentially talk to this DB. So you are taking in an maybe an ID, like ID from the home. Every home can be assigned a unique ID. You're taking that ID, updating whatever information you want to, and you are putting it over here. Of course, for the sake of making sure people are not messing around with the system, where updating inaccurate information, there could be some kind of a verification process over here, whether automated or manual, to make sure that whatever information the users are entering, that is correct over here, or at least they are able to verify that they own the home, and they are able to update that information.
Got it. Yeah, that's important for trust and safety on the platform.
Yeah, exactly. The other thing I can talk about, we spoke about search and update. So what are some of the core APIs that the system would kind of handle over here? So one is our search API. So essentially, the search could take a wide variety of parameters over here. So you could essentially give your complete address with street name and everything. You could just give your zip code. You could give a county or a city. So based on any of these parameters, you are able to know which shard you need to go to, and pick homes from there. The second one is your update. So essentially over there you're looking at the ID of the home, and then you are kind of updating whatever parameters you want to. So like if this were like a kind of a JSON payload over here, so let's say you are updating the just your layout or your floor space. So you could add any parameters over here. um, the other thing we can also talk about is like a slash recommendation API. So when you search for a particular home, you're obviously given that home, but alongside that you can obviously also be given other homes that match that similar criteria. So let's say um, what that criteria is, that we can kind of have the system dictate. So you could think of it as that we have like a recommendation system over here, a recommendation engine, which is looking at this database and essentially given a zip code, given the house it is that you specifically searched for, it knows the parameters. It knows how whether it's a single family home, a townhouse, what is the price range, how many bedrooms it has. Based on that criteria, within the same zip code, it can look for homes that match the same criteria, and it can return that to the user as well.
Cool, makes sense. Do you mind walking me through your system design here and showing me, hey, like I'm a user, I'm looking for a house, like how do I go through your design? How does it work?
Sure. So basically, as a user, as I said, right, you come onto the website or the app, you have a search bar. You either have a specific address in mind, uh, or a zip code or a city. You basically put that in. The more looser the search it is, the more number of results you would get. So you basically go to the search service. If let's say you start off with a specific address, we would go to that shard, pick up that information about that home, and then show that to the user. In the meanwhile, you would along with that, actually this could kind of come here, where the recommendation engine also updates the same in given the search criteria. It will also find similar homes that match that pattern and send that along with the search result. So you see the main home that you search for, and then on the side you see similar homes. In case you want to update a home, I think one step you would do is essentially claim ownership of that home. So there could be some kind of a API over here when you're updating it, like so if I were to do is to a like slash claim, and then you would say that the ID of the home, so that, and give some information that how to prove that you have ownership of the home, um, and then you could kind of make the necessary updates if needed. Obviously the next step in over here is basically listing. So essentially, if you are buying or selling an home, and a listing is essentially from the seller's point of view. So once, I think step a would be to claim your home, and then listing is essentially being able to list that home for sales where others can buy it. So I think essentially from a user standpoint, when you're listing, it's nothing but in some sense an update with some field, let's say whether it's called available for sale, flagged as true, and then obviously you can determine the price and all, and then there is yeah, go ahead.
Okay, I was just gonna say that like this is a good system design, and I'm happy that you're walking me through this. Are there any opportunities for caching here to optimize the design?
Yeah. So I think definitely what you can cache is, there are two very one specific area that you can cache over here, is on the user standpoint, right? When users are looking for homes, they generally look in a particular area, right, in a particular geography. So once they start looking for something, once the load balancer responds, you could technically have some kind of a maybe a cache over here, um, caching the response from your service, from your search service, right? Not just your primary home that you've searched for, also recommendations and data about the recommended home. So if the user is clicking around on those homes, that information is available very quickly. And in case the user even comes back again and searches for the same homes or in the same zip code, this information is already cached. So you can kind of almost have some kind of an LRU cache where if the user is recurringly searching for the same homes, that cache stays fresh.
Cool. Yeah, I think one other place could be maybe like trending homes. If there's some homes that are trending that many people are often looking at in the recommendation engine, for example. But all in all, thank you for the system design here today, Josefa. I think we can stop the mock interview here. And I'd love for you to maybe give the audience some tips on their future system design mock interview or their future system design interviews.
Sure. I think system design in interviews in general are very, very open-ended. It can cover a vast breadth as well as depth of knowledge. So what I recommend everybody is to have a few requirements from that you want to kind of focus on, go into details of those requirements rather than trying to boil the ocean over here. There is no right or wrong answer in a system design interview. Whatever you decide to whatever system you decide to choose, whatever technology you decide to choose, I would say just validate that with why you've decided to do that. I think any systems, any large scale systems, right, that generally get asked in system design interviews were not designed in 30 minutes or 45 minutes. So it's been years of efforts by hundreds of engineers, and nobody expects you to come up with the right answer in 30 minutes. So the idea here is just thinking through the problem rather than trying to get to the exact answer.
Yeah, absolutely. And just to add on top of that, surfacing trade-offs, talking about, for example, like how Josefa talked about the NoSQL database versus SQL databases, being able to talk about pros and cons for storage, schema, querying, scalability, definitely helps in your 20-30 minutes that you have with the interviewer. Thanks again, Josefa, for your time, and for the audience watching this, good luck with your upcoming engineering management, or system design interview.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.